Hi everyone, my name is Marie Elise and I'm with the University of Rhode Island's Inner Space Center. My background is in geology and geological oceanography. This is actually my first time on a research vessel. I'm excited to be here and I'm excited that you get to share this experience with me. From now until September 6th, we're going to be broadcasting live with scheduled shows at 11, 1, and 7. These shows will be broadcast on Rhode Island PBS and also online at innerspacecenter.org/RIREX. Joining me now is Dwight Coleman, who's the director of the Inner Space Center, and is going to tell us a little bit about what we can see on this cruise.
Great. Hi. Thanks, Marie Elise. Yeah, I'm Dwight Coleman. I'm the director of the Inner Space Center at the University of Rhode Island Graduate School of Oceanography, and we're on board the research vessel Endeavor. So the Endeavor is part of the Graduate School of Oceanography, and it's owned by the National Science Foundation, and we're fortunate to be using the ship on a special program, which is called the Rhode Island Endeavor Program, where the state of Rhode Island provides funding to Rhode Island-based scientists to do Rhode Island-based research. So here we are, standing just about 6 miles or so off the coast of Block Island. We're just about on top of the wreck of the U-853. We're preparing an ROV, a remotely operated vehicle system that's going to be diving on the wreck. Hopefully we launch it during this broadcast. You can see the launch of the ROV. And the team from the URI Ocean Engineering Department has been working very hard to get the ROV ready. We've had a few technical challenges. There's some electrical issues that we've been struggling with a little bit, but I think we've got all those solved now. And hopefully we can get down to the bottom and see the wreck for the first time, because we haven't been able to do that yet. So we're pretty excited about that on this cruise. We have a whole team of multidisciplinary scientists and engineers and students and graduate students, mostly based from the University of Rhode Island. We have representatives from the Ocean Engineering Department. We have Tom Rossby from the Graduate School of Oceanography, a physical oceanographer who's running some of his experiments this week. We have Gody Fisher from the Electrical Engineering Department of URI. And we also have some colleagues from the U.S. Coast Guard Academy. So Rich Sanders and Gabe Patterson have a small ROV themselves, the Seabotics ROV, and they're going to be doing some dives on the shipwreck as well. So we're pretty excited to bring this whole project live in partnership with Rhode Island PBS and also live to the website so that all of our viewers can kind of follow along live. So we're pretty excited about this project, and I know we have some special guests to bring in and talk about what we're about to do, and hopefully we can go see some of the live action out on deck as the engineering team gets the ROVs ready, and we can watch the start of this dive, hopefully. So back to you, Marie-Elise.
Thank you. So next we're going to talk to Captain Rich Sanders, and he's going to tell us a little bit about ROVs. And Shannon Donovan, are you going to join us as well? Excellent.
Wonderful.
Let's start with what is an ROV?
What is an ROV? An ROV, a remotely operated vehicle, is in our case a vehicle that we can send below the surface of the water, and we can look usually via video. We can use sonar, and we can put other sensors on it, and we can look everything from shipwrecks like we're doing. We could look at submerged structures. We could also use it for things like hull inspections on ships to see what kind of condition the ships are in. And the ROVs, what's nice about them is, unlike, say, manned submersibles, where you might think of Alvin or other types of submersibles that require people to go down, ROVs can go down and stay down for almost an unlimited period of time. So there's a start, and we have two of them aboard.
Great. Why don't you tell us about your ROV and what you're going to be doing with it on this cruise?
Well, we've already had some successful deployments. Our ROV is called a Seabotics LBV Little Benthic Vehicle 200. The ROV weighs only about 25 pounds. You can carry it easily with one hand and put it over the side. And we have, earlier today, tested some systems. We brought it down. We looked with sonar and also with the cameras up at the ship's hull. We saw the propeller rotating, and one of the most exciting things we did today with our ROV was to have our esteemed teacher and communicator aboard, Shannon Donovan, to be able to talk to be able to learn how to operate it. And Shannon, let me introduce you.
My name's Shannon Donovan.
Excuse me, Shannon.
That's okay. That's not the first time I've been confused with that famous person. So I am a teacher at Scituate High School, and I am so excited to be part of this expedition. This has been a dream of mine to be on this ship at some point, and it's met every expectation that I had. And Captain Sanders and his cadet Gabe Patterson were gracious enough earlier today to teach me how to drive their ROV, and I got to pilot it below the ship, and we drove around a little bit underneath the ship to look at some of the features from below, and then we went to depth just to kind of see how far we could go and see what the visibility was like, and got to see some ctenophores and comb jellies and so forth. So that was a really amazing experience. One of the reasons I applied to participate in this program at this time is because last year I started teaching robotics at Scituate High School, and we're involved in the First Tech Challenge. And I am learning right along with my students how to approach these challenges, and so I thought this experience might give me some more tools to bring to my students to help us work on our designs and to think about how we approach frustrating situations. So some of our engineers have had to deal with some frustrating situations on this trip, and watching them work as a team to troubleshoot and problem solve has been a really great experience. They demonstrate gracious professionalism all the time, even when they're tired and frustrated. And I say gracious professionalism because that's one of the tenets of FIRST, and something we try to work. So the character development that happens along with that program. So thank you so much for that opportunity earlier today. It was a real treat.
I could say you're a fantastic pilot.
So outside right now, they're setting up the ROV to go into the water. It looks like they've just hooked it up to the crane, and they're getting ready to put it over the side. Why don't we talk a little bit about the troubleshooting that they had to do yesterday, because I know you saw them do some pretty cool things.
Right, so I got to watch the deployment of Deep Reef. That's the larger of the two ROVs that we have aboard. And so they hoisted it off the deck with the crane, swung the crane out over the water and slowly lowered it. They had the tether line that carries the signal from the lab where the pilot is situated, and that remains intact, remains connected to the ROV. But then they had another line that allowed them to disconnect the ROV from the crane line, the cable that lowered it into the water. So they did that successfully, no problems, and started to navigate a little bit near the surface. But when they attempted to go to depth, they encountered a ground fault. They were leaking electricity into the ocean, and so they had to stop operations, carry out the recovery procedure to hoist the ROV back on board, and then they started their problem solving. They evaluated some of the systems. There are a lot of systems that they have on this ROV because it has a lot of different capabilities. And they decided at that time to remove the lower portion of the ROV, which they refer to as the sled. And some of my students got to see a little video that I put together last night about this on my website. So they removed that, and this sled is filled with hydraulic lines, electrical components, lots of things to maneuver around. So they have to when they take out a component to test it, they have to do so very carefully so as to not damage any other parts. So they had this canister that had been removed. They took it apart, and just using a simple multimeter, Steve was going around testing the various circuits in there and found a loose connection and thought that was the source. They tightened that up, they resealed the unit, reassembled it, and ran another test today, but that apparently was not the source of the problem. So they have been systematically, as the day has gone on here, systematically removing components and testing it to see if the removed component was the source of the ground fault. I'm not sure where we stand right now with it, but I know they're getting ready to launch it, and hopefully we'll have some luck here.
Excellent. Rich, you've used this ROV before, correct?
That's correct.
Is this what you usually use it for?
That's right. What we have been using it for is subsurface, to be able to do surveys, to be able to do sonar work, and specifically we use this ROV to help in some corrosion research, which is cadet directed. I oversee it as the cadet's advisor. we are taking a look at corrosion rates of submerged structures like shipwrecks, and our concern is that there are shipwrecks that are under that may carry oil or petroleum in them. USS Arizona is a very famous example, and in fact, when we started this research, we were lucky enough to contact the National Park Service and some researchers actually from the University of Nebraska who've been instrumental in helping us to learn how to do this, and also providing us with samples of metal to learn how to determine corrosion rates. So now what we're doing is we're taking work that was done on the West Coast and in the Southeast area, and we are working to expand this to modeling it in the Northeast with our weather conditions and our seawater conditions. Shannon?
So what are some types of measurements that you and Gabe and your team hope to collect at these different wreckage sites that will help you build your model about corrosion rates and about how quickly some of these wreckages might decay and cause a potential hazard?
That's a wonderful question. Thank you so much for asking. There are essentially three components that we are looking at. The first component is we want to know something about the metals. We want to know what the metals are made of. Steels are comprised of iron, but also different materials. We want to know how the metals are connected together either by welds or rivets, which leads to some interesting consequences potentially. And we want to take a look at the marine growth that occurs on the wrecks outside of the metals. That can give us some indication of corrosion rate if we actually analyze kind of the hard, we call it concretion. It's almost like a cement type material that ends up building up outside the hull. And then finally, we need to know something about the salt water that the wrecks are in. So like today when we've been diving, and now with the Falcon, with the deep reef, we will be collecting conductivity, temperature, depth, and dissolved oxygen measurements to get an idea of how fast corrosion might occur or the conditions to evaluate corrosion rates underwater.
Okay, and the other night when I boarded, I had the opportunity to board the night before we actually left port, and the captain was here with Gabe, and they were doing some tests right in port, and I got to watch that and start to pick their brains. And you were starting to tell me about some different types of corrosion. You want to talk a tiny bit about that?
Sure, there are a number of different types of corrosion that occur. One is just a straightforward corrosion where a metal will rust away. In the case of iron, you end up getting different areas on the metal that become dissimilar, and without going too far into the chemistry, we get some electron flow. One area develops electrons, another area becomes deficient in them, and when this happens, we end up getting areas where the rust will form, the metal will oxidize because it loses electrons, and flake off. Now, there are other types of corrosion that occur. There are things called crevice corrosion, where you can get little cracks or areas that accelerate corrosion. And also we are concerned, there's a type of corrosion called galvanic corrosion that we're looking at, where you have two different metals. And if those metals are in electrical contact with one another, either touching each other or some way through a wire that electrons can flow, if they're different, one metal will corrode, giving up the electrons to another metal. And this is both bad because it could create a situation where we get, say, larger holes while corrosion is occurring, or it could be good because we can take a metal that we don't want, connect it to one that we do, and we could save the metal that we do, like putting, today, zincs on ships.
That's great, and I have a lot more about that I'd love to talk with you about further in the live broadcast later on the website, and a shout out to my need peeps that have done the Apple battery experiment, because what the captain was just talking about is exactly related to that. But I'm going to pass it back to Marie-Elise to help us wrap up.
Well, thank you both so much for joining us. We really enjoyed having you on the show. And actually, next we're going to talk to Mike Brennan, who is a marine archaeologist for the Ocean Exploration Trust.
Thank you, Marie-Elise.
Thank you. Hi, why don't you start by introducing yourself?
Sure. Hi, I'm Mike Brennan. I'm a Director of Marine Archaeology for the Ocean Exploration Trust and an Expedition Leader for the Exploration Vessel Nautilus. I was a graduate student at University of Rhode Island Graduate School of Oceanography for too long, for 8 years. And we did a lot of work on ancient shipwrecks in the Black Sea and the Mediterranean. And now we're out here. We've done some U-boat work on Nautilus. Last year we looked at the U-166 that was sunk off of Louisiana in the Gulf of Mexico. And so now we're out here with Endeavor. We're about to dive on the U-166. No, the U-853.
There's a lot of them.
Yeah.
Is there anything in particular you're going to be looking for when they're at the site?
Yeah, well, the site's been dove by scuba divers quite often, but I don't believe any ROVs have ever been used down here. And so one of the goals of using ROV is it's safer than it is for divers, but also divers only have themselves and some of their cameras to look at a wreck, but we're able to use ROVs to come live to the public. So it's a good medium for televising the video of this really cool site. But also we want to look at what the site looks like now. So there's a lot of reasons to go back to a shipwreck periodically, archaeologically. We want to look at potential damage to the wreck site itself. So the ship was damaged by depth charges, which is why it sank in 1945. But how has this site kind of come into equilibrium with the surrounding water? So we have corrosion, we have growth of sponges and corals or other marine life. We have potential damage from being draped on with fishing lines or trawl damage from fishing gear that's it's been an obstruction to. And so we want to go down and take a look at what the wreck site looks like. Every couple of years, some wrecks can change quite drastically based on both environmental and anthropogenic parameters. And so we're going to do that. And there's also some things at the site that can pose hazards. So we have potentially unexploded torpedoes still in the wreck. There has been documented at least one depth charge that's unexploded that's still at the site that never went off from when they were trying to find the boat. So there's a lot of reason to go back and look every couple of years. Things can always change.
Oh, it looks like right now we are launching the ROV. Are we going to switch to the outside feed so the public can see? Excellent. So it looks like they're just doing a final check here to make sure it's ready to go over the side. Mike, how do you use ROVs?
Well, so on Nautilus we have a ROV called Hercules, which is one of two. The other one is Argus, and Argus is a camera sled, which is a large steel cage that has cameras and lights, and that flies above Hercules as kind of an eye in the sky. Hercules looks very much like the Falcon here, which you see being put together, but it's a lot bigger. Hercules is about the size of a Humvee, which is actually a small ROV by oil industry standards. And so what you see right now is the red and the yellow at the top is a syntactic foam float, so that gives the ROV its neutral buoyancy to offset the weight of the metal and the other instruments on the vehicle. We have these floats on top to give it neutral buoyancy in the water. There's a steel box at the very top, which is the high definition camera. And then the cage is made out of plastic, so it adds to the lightweight. And the box that's on the ground that they're putting the top of the vehicle back onto holds the hydraulics for the mechanical arm, which we're going to be testing out later off of the site, not part of the wreck, but we'll be trying to pick up some things and testing out a new sampling system that Dr. Stephen Licht has come up with his engineering students. So we'll try to get a paper rock and kind of experiment with that. So they've just placed the top of the vehicle back onto the bottom of the vehicle, and we will be diving momentarily on the wreck of the U-853. The orange little box that you see on the left of the vehicle is a CTD that is inclusive in itself, so it logs within it internally rather than being streamed to us on board the ship. So we'll be getting some good data around the wreck. The oxygen and the temperature and the conductivity, which tells the salinity around a steel wreck site, can tell us a lot about the corrosion parameters. So we'll be looking at the profiles of the chemistry and the physical properties of the water as we descend towards the wreck, which could change when we get closer to the wreck site.
Excellent. Well, thank you so much, Mike, for joining us. And I think now we're going to talk to Captain Bill Palmer, who's at the Inner Space Center. He's an experienced diver, and he's actually one of the people we consider experts on this wreck. Can you hear me, Bill?
Yes. I'm Bill Palmer, and the reason why I'm here is because I wrote the book on the U-853. I mean, literally, I wrote the book on the 853. And what to me is that doing the Endeavor is just 130 feet away from the last German U-boat sunk in World War II. So, again, I'm here for my expertise. And let me pass the mic over to my associate, Robert Zimbrola.
Call me Bob, please. I'm Bob Zimbrola from the Naval War College. I've been diving. I started diving in 1972. I worked on my first shipwreck the next year in 1973 with URI on the wreck of HMS Cerberus and Orpheus, which was scuttled in 1778 right here in Narragansett Bay. So I'm very intrigued by this because I've been on the U-boat before, of course, via scuba, so this is a lot more fun. You don't have to get wet. There's no gear to wash off, no decompression to do or worry about. So I'm looking forward to this quite a bit.
She was found and sunk by the Atherton, the Erickson, and the Mulberry. And what sort of intrigues me or interests me or makes me wonder is that prior to leaving Norway, Captain Firmstorff, who was the captain of the 853, went to visit with Captain Summers, who was wounded on a previous patrol. And Captain Summers said to Captain Firmstorff, "The war is nearly at an end. Do not be frivolous with the crew. They're all good boys. Make sure you bring them home." And Captain Firmstorff assured him that he would.
So we may be having some technical difficulties, but we can still look outside at the ROV and see what's going on out there. It looks like they're starting to get pretty close to launch time.
Yeah, so Bill Palmer was about to talk about what happened on the fateful day that the U-853 was sunk. So it had just sunk the USS Eagle in Casco Bay, Maine, and it was coming down towards southern New England, and it encountered off of Point Judith, Rhode Island, the Black Point, which is a steamer carrying cargo of coal up from Virginia on its way to Boston, and it sank that ship, and then that started a kind of a manhunt for the submarine with the U.S. Coast Guard first, and then some other Navy craft, and they depth charged in the area, and there's even a picture of some Navy blimps coming in for the search back in 1945, and then they cast depth charges over the side, and the way that they know that they got the U-boat was that debris from the wreck, and even a captain's hat floated to the surface. So they then sent down Navy divers to confirm the kill, and so it sunk here just off of Block Island, Rhode Island.
Wow.
So we're getting ready to launch, it looks.
Yep.
We hope.
Oh, we switched to outside. It does look like they're getting ready to launch. It's all hooked up. But I'd kind of like to continue talking about U-853
Sure, yeah.
while we're watching this footage here. It's my understanding that these shipwrecks can be very dangerous to divers.
Yeah, so divers have to be very careful when they go inside a wreck because there can be jagged steel from the opening of the hull that they usually use to access the inside of a wreck. So that can be detrimental to your skin, your hoses. You can also find that you run out of air inside, and unlike normal diving, when you can come to the surface, if you're trapped inside, you can't do that. So you have to be very, very careful diving inside of a wreck. It's similar to diving inside of a cave where you need to know where you are. You need to have reserve air on you and know exactly how much air and how much time you have inside the wreck.
All right, well, it looks like we have a question from our live chat. The first one is, how long is U-853?
U-853 is 252 feet long, which surprised me. I had to double check when I first saw that number because that seems extremely long. It's a very large U-boat, but it's also very skinny. But it's actually about 100 feet longer than the depth in which it sank, which kind of blew my mind. So if it had sunk from the surface just nose deep, it would have been sticking out still. And that's longer than the ship we're on now. It's longer than the exploration vessel Nautilus. So it was a very long submarine, which is kind of fun to think about that it actually sank in water shallower than its own length. And the depth that it sank in is about 37 meters, which is about 120 feet.
Excellent. So I'd like to ask the divers at the Inner Space Center, hopefully they can hear me, what condition the wreck site is in. Whoever thinks they can answer that question the best.
Sure. I've been diving the 853 since 1973 when I first found it. This is Bill Palmer, by the way. Excuse me for not introducing myself. But again, I've been diving the 853 since 73. And I was on it maybe 2 weeks ago. And it's falling into a state of decay. The bow is falling off. That's going to the starboard side. And when I say bow, I'm talking primarily of the outer hull and not the pressure hull. As you swim, excuse me, as you swim towards the stern, she's almost broken in half. The stern is falling down. There's a large hole there which is directly above the after torpedo room. And at one time that was pretty well straight, but now it's fallen down and it's twisted off to the starboard side. The interior of the boat is almost the same as the first time I dove it. It's probably maybe a quarter filled with silt and mud. The torpedo that was in the forward torpedo room is long since gone. And the bulkhead walls have deteriorated except for the pressure bulkheads. But, they used a lot of wood in those boats, so those wooden pieces are long since gone. And like I say, it's filled probably away with silt. So,
Okay, well,
what else can I tell you about?
We actually are all out of time and have to wrap up. Thank you so much for joining us today.
Thanks so much.
I want to remind everyone that we will be continuing to stream live on innerspacecenter.org/RIREX. Thanks for joining us.